Hello students, today we will be moving on to a broader topic in AutoCAD, that is AutoCAD 3D, right? Now I am feeling very happy that you people are enjoying the video lectures that I have uploaded in YouTube, and correspondingly I have been uploading the links in the Google Classroom of your respective departments. I hope that all of you practice in your home and work on the assignments that I have given related to all assignments regarding the AutoCAD 2D as well as the isometric concepts that I have recently uploaded, right? So today's topic is about AutoCAD 3D. I know most of you were waiting for the same. This has to be discussed. This has a broader application in the field of engineering. So let us start. Okay. So for understanding the AutoCAD 3D, the first thing that you have to know is that you have to understand the interface related to 3D in AutoCAD. Okay. So first thing that we will do is we will change the workspace from here and we will change it from drafting and annotations to 3D modeling. And as soon as you click on 3D modeling, you will be able to see that the basic interface has been changed to AutoCAD 3D interface. It can be clearly visible in the ribbon section of the AutoCAD interface. You can see that now the 2D commands more or less has been replaced with the 3D commands, and with the help of this you can easily work in the 3D in AutoCAD. Okay, so first thing, you have to keep this in your mind that whenever you are working in 3D or you are working on a model which has to be represented in 3D, that is in 3 dimension, you must have a clear concept about the 2-dimensional concepts in AutoCAD. Okay, so without knowing the concepts, without knowing the details in 2 dimensions, 2-dimensional approach in AutoCAD, you will face serious problems working in AutoCAD 3D, right? So I suggest that you go through my previous lectures. Those who have attended the classes, you won't be facing any problems, but those who have missed or skipped the classes due to some reasons, you will be facing some problems, and I suggest that you go through different online material, my YouTube videos, as well as you discuss with your classmates and understand the topic that were discussed previously. Okay, so get a clear concept about the 2D concepts and then come and work on 3D. Okay, so let us start. So for starting the 3-dimensional modeling in AutoCAD, you will have to understand few things. Okay, so let us take an example and we will be discussing about various comments. Okay, preferably we will understand the interface on which we were working. Okay, so if I will consider or what we will do is we will construct an 3D object, an arbitrary 3D object first. Okay, so let us consider that the dimensions of the object is in this particular conditions you are having length, breadth and height, because it is a 3-dimensional object. So in this case, firstly what we will do, we will set the limits. Okay, so let us set an arbitrary limit for our drawing. So lim limits, click on enter. Then the lower left corner will be set to 0, 0, so 0 times 0, and let us assume that the upper right corner is set at 200, 200, and we assume that the drawing will be properly enclosed within these dimensions. Okay, so click on enter and Z enter, A enter. So now the limit has been properly set and we have already extended the zoom option. Okay, now let us create a rectangle first. So let us consider this rectangle command. Okay, so firstly I will specify the first corner. So I have specified an arbitrary position, which is the first corner, and I will give the dimensions or the area whatever it may be available to you. So I am for these conditions I am giving the dimension to be suppose 150 as the length of the rectangle, and click on enter. And the width of the rectangle let us consider to be suppose 75. Okay, click on enter, and as you can see clearly that the rectangle is formed. So I will click on any other corner, specify the corner. So I'll click on an arbitrary position and our drawing here, and as you can see that the rectangle is formed, right? Now the rectangle that we have formed here is actually a 2D object. How we can understand that the object is in 2D? Because we know that we have got two axes here which represents a plane, that is the x-axis and y-axis, right? This x-axis and y-axis are mutually perpendicular to each other, and this x and y-axis forms a plane on which we draw the two-dimensional objects, okay? But when we come and consider the condition regards to three-dimensional modeling in AutoCAD, then we must have another axis, which is the z-axis. That means now we have x-axis, y-axis and z-axis, which all of these three axes will be mutually perpendicular to each other. Okay, so what will be the position of the z-axis? That we can understand that the z-axis will be pointed towards us if we consider the plane formed by x and y-axis as our computer screen. So we can take an example here. So if you see that if we consider the left hand rule here, if this finger is pointing towards the x-axis and the thumb is pointing towards the y-axis, then the other finger pointing towards us represents the z-axis. And it has to be kept in mind that x-axis, y-axis and z-axis, these three axes must be mutually perpendicular to each other. So you can understand here, it is clearly written over here that when the user holds the left hand with the forefinger pointed towards the positive x-axis, you can see the forefinger which is pointing towards the positive x-axis, the thumb is pointing towards the positive y-axis, then the middle finger will be representing the direction of the positive z-axis, and which is actually directed towards us if we consider x and y-axis forming a plane which corresponds the screen of your computer. Okay, so in this condition currently we are not able to see the x and we are not able to see the z-axis here. So in this condition we must draw a 3D object in order to get the representation of the z-axis or the z-axis, what you say. Okay, remember one thing, that when you are producing a 2D object or transforming a 2D object in a three-dimensional object, in that condition the 2D object will be extruded along the z-axis, right? So for example, if you consider, we have got a command here which is known as extrude. So I will click on this extrude option, and when you click on this extrude option here, so it's asking me to select the object to extrude. So if I want to select this object and click on enter, then it is asking me to specify the height of the extrusion, as you can see. So if I specify the height of the extrusion to be suppose 75, click on enter, then the object has been properly extruded along the z-axis. Okay, but it is not visible here in the two-dimensional plane which is formed only by the x and y-axis. So how to see the three-dimensional representation of the object? For that we have to understand few things. Okay, so for understanding the concept or the representation of an object in a three-dimensional plane, we have got an option here which is known as the, you can see this looks like a compass, right? So you can see north, east, west and south options are available. So this actually is known as the Viewcube in AutoCAD. Okay, so this Viewcube will help you to navigate different views of an three-dimensional object. Okay, so in this Viewcube you can see that there are many clickable options or clickable points available. So you can see there is one clickable point here, another clickable point here. On the corners also you can see that there are various clickable points. These are known as the hotspot in the Viewcube. Okay, now in this position you can clearly see that the top face of the object is exposed in front of you. So this you have to understand that this is the top face of the object. For example, if I click on this viewport, or if I click on this hotspot, then see what happens. If I click it here, then as you can see that the Viewcube has changed its orientation, and the top face, the left face and the front face is exposed in front of us now. Okay, and now here you can clearly see that we have got the introduction of a new axis, which was the Z axis, which I was talking previously. Okay, so you have got the X axis, the Y axis, and currently the Z axis is also available now. And as you can see, previously our rectangle was this one, and the object has been extruded along the Z axis, along this axis. This axis is perpendicular to the plane formed between the X and the Y axis, right? So this view cube will give you several options in order to navigate between different views of a three-dimensional object. So if you click on this hotspot, you see that only the top and the front view of the object is exposed here. Okay, if you click on this point, you can see that the object is now represented in exposing the top, front, and the right side of the object. And as you can see, this type of view is known as the southeast isometric view of the object. If I click on this point, then this is the southwest isometric view of the object. Okay, so let me tell you that the southwest isometric view of the object is the default view in AutoCAD 3D. We will be normally keeping our object in southwest isometric. You can keep it in other views also, but in normally what we do is we keep our object in southwest isometric and then we work on it. Okay, so this is actually the isometric view of the 3D object. And as you can see that when we were discussing about the isometric concepts, it was clear that the three faces of the objects were clearly visible in front of you. Here also you can see that we have got the left, the front, and the top face exposed in front of you, and this line is at an angle of 30 degree with the horizontal. This line is at an angle of 150 degree with the same horizontal line along this direction. So you can understand this is actually the isometric view. But if you are navigating through this view cube, you are getting the true three-dimensional representation of the object, which unlikely we have done in case of isometric concepts. Okay, the previous one, don't mix this AutoCAD 3D with the previous concepts of isometric, because what we have done previously was the representation of an three-dimensional object in a two-dimensional plane. But here what we are doing is the representation of a three-dimensional object in a three-dimensional plane. Okay, how three-dimensional plane? Because we have now got X, Y, and Z axis, but in the previous case we have only the X and Y axis available. Okay, so you can understand the difference. Now this view cube has if you click on this view cube here, you can see that there are many options available. Kindly keep in mind that if you click on this home button, then you can see that there is a little bit of difference coming. So if you right click here, you right click on this option, you can see that there are many options available, that is parallel and perspective. We don't have to concentrate on the other options for the time being. You can also go and see the view cube settings also, not an issue. We don't require this for the time being. So we will only concentrate on parallel and perspective view of the object. What is a parallel view? The current view that you are seeing here is the parallel view, where the edges of the objects are parallel to each other. You can see this line is parallel to this line. That means this edge is parallel to this edge. Again, this edge is also parallel to this edge. Again, this is parallel to this. So you can understand that when we are considering a parallel representation of the object, then all the edges are parallel to each other. I mean, the corresponding edges are parallel to each other. So when you are shifting your view to perspective, then see what happens. If you click on this perspective option here, then you can see that the edges of the object are now not parallel to each other. I mean, the corresponding faces of the object are not parallel to each other. This, if you consider an example that if you are standing in the middle of a street, then the face of the street, or the portion of the street which is in front of you, on which you are standing, looks to be broader. The farthest portion of the street which seems to be converging to a point. So let us change the type of view to parallel. and let us keep this in southwest isometric, which will be the default view in our condition, and we will always try to keep this in southwest isometric, and we will try to keep this in world coordinate system for the time being. I will tell you in a different lecture how to use or how to create a new UCS, that is the user coordinate system, later on. Okay, so I'll try to keep this in always in world coordinate system, keep this in parallel, and here as you can see that the x and y axis is represented along this direction, these two directions, and z axis is along the other direction. All of the three axes are mutually perpendicular to each other. Okay, now as you can see here that there are a few options available. So for example, if I can also navigate from here and change the views of the object. Suppose I want to get the top view of the object, then I will click on top, and as you can see that the top view of the object has been visible in front of you, and now you can see the representation of the x, y and z axis. So preferably the x and y axis is visible, z axis is pointing towards us. Okay, so in this condition you can also change it to bottom, you can change it to other options here also, you can change it to southwest isometric from here also, just similar to that where you have changed it from the Viewcube. So southwest isometric from here you can change it to southeast isometric. Like this you can also change it by navigating through the options from here. So as you can see there are other options, parallel and perspective, which were available in Viewcube also. So from here also you can keep it. Okay, so I will what I will do is I will click on this home button, and we will change this to WCS, because the user coordinate system has been changed from WCS to a specified user coordinate system. So I will keep this in WCS, and in WCS as you can see x, y and z axis are pointed in this direction. Okay, so here I will keep this in southwest isometric. I can keep this in southwest isometric, and I will keep this in 2D wireframe. Okay, so this is how it looks like. Now there is another option here from where you can change the type of visual styles. As you can see, custom visual style. So you can click on this conceptual option. If you click on this conceptual option, the conceptual representation of the object will be shown to you. Okay, you can click on this hidden option. If you click on this hidden option, you can see that the back faces of the object are not visible in front of you, only the faces which are exposed can be seen. Similarly, other options, realistic option is there. You can see it's the realistic representation of the object. Okay, shaded option is there. So this looks like the shaded option, shaded with edges. You can see in this condition the edges are also shown, as well as the surface of the objects are also shown from here. Similarly, sketches or shades of gray option is there. You can see sketchy option, it will give you the representation if it would have been drawn in a hand sketched manner. Okay, similarly wireframe is there, it's more or less similar to the 2D wireframe option. It's wireframe, 2D wireframe, more or less same. X-ray option, you can see it's the semi-transparent type of view that you can get for the object. Okay, so this is how I will try to keep this in 2D wireframe here. I can also switch off the grids from here in order to work in 3D. I preferably want to keep the grids off when I am working in 3D, but in 2D I like to keep it on. So I have kept the grids off for the time being. There are other options also for changing the different type of views. As you can see, if I click on this option and click on the show menu option here, you can see that the menu can be seen from here. You can see file, edit, view, insert, like this many options are available. So if I click on this view option, you can see that here also 3D views are available, options are available, top, bottom, left, right, front. You can navigate from here also. Click on the respective option and change the type of view. Okay, we have got viewports also. I will discuss about viewports later on. Okay, there are other options available also. There are other options available here which is known as the quick access options here, where we have previously used the pan option from here. So I can pan in and out from here. I can zoom extend the option. You can see that if you click on the zoom extend option, there are many options available. So I click on zoom extend, then the limit that I have set will be taken. Limits that I have set will be taken as the default I mean the space on which the zoom can be made. You have got another option here, orbit option is available. There is a orbit option here. So if you click on orbit, you can see our cursor has changed. If you click on left click on the screen, don't remove the left click option, and if you move the mouse, you can see that you are getting the representation of the object. You can actually orbit the object and see different faces of the object clearly. Okay, similarly free orbit is there. So if you click on free orbit, then you can move it along different directions. So similarly this is the free orbit. Okay, and the continuous orbit is also there, so you can give it a, I mean in the direction, in the specified direction, you move your cursor by left clicking on it on the mouse, and it will slowly show you the representation of the object in different, from different views. Okay, so you can actually understand that how, and as you can see that as I have changed it, the Viewcube has also changed. And right click exit, and I will change this to WCS, and I will click on this home option, and I will right click and click on parallel option. Right, so we have come to the southwest representation or southwest isometric representation of the object for the time being. So you can work on this option also. You can, I mean, you can go to this view option, and this visual styles, you can click on this realistic option and you can work on it. Okay, so this will be convenient. You can use different type of views in order to understand the different views that will be available in front of you. Okay, so for this lecture, up to this, in the next tutorial we will be discussing about the various commands that we extensively use in when you are working in three-dimensional concepts. Okay, so thank you for the time being. Thank you all.